welcome you. This is my first video about computer architecture basic concepts. So in this video we are going to discuss some fundamental things in computer architecture. First I will show you simple connection in computer, how the various components are connected using a single bus organization. So in this picture there is a arithmetic logic unit and registers and special purpose registers like PC, IR, MAR, MDR, and general purpose registers. So this is how a simple connection in the computer. So we will discuss the registers, what is the purpose of these registers in the next slide. So the first one is memory address register. It holds the address of main memory from where data is to be transferred. So MAR holds the address of the data to be fetched or read in or placed into memory. The next one is program counter. So program counter is one of the special register, and it holds the address of the next instruction to be fetched or executed. So it automatically increase one by one, and it loads the instruction into the instruction register. That is next one. So instruction register shows the instruction that is currently being executed. It gives the operation to the control unit to generate the timing signal that controls the execution. So every instruction to be executed is to be brought to the instruction register. Then depending upon the instruction types and formats, the control unit generate the timing signals and other signals. So next, MDR, that is data register, memory data register or buffer register. So it holds the data, mainly of data which is write into or read out of the memory location or addressed location. So next one is registers, that is general purpose registers. General purpose registers normally is R0 through Rn plus 1 is used for storing data. Next one is the main part, control unit. So control unit means it contains the memory, arithmetic and logic unit, input output units, store and process information and perform input output operations. These operations units must be coordinated in same way. This is the task of the control unit. So in other words, control unit is the brain of the computer. So next we will see about the registers and register transfer. So register is a group of flip-flops with each flip-flop capable of storing 1 bit of information, and n-bit register as a group of n flip-flops and is capable of storing binary information of n bits. So the set of flip-flops or group of flip-flops is connected. If you want 8-bit, we have to connect 8 flip-flops. Suppose I want a 16-bit register, then 16 flip-flops has to be connected. So registers is a very fast computer memory used to store data and instruction in execution. Next, register transfer language. So register language is nothing but the micro operations which is used to transfer from one register to another language or another register is mentioned or using some notation. So this notation is called register transfer language. So some example, that is R12 registers. I want to transfer the information from R1 to R2. Then the notation is R2 to R1. It denotes the transfer of data from registers R1 to R2. So basically we are transferring data from one register to another register depending upon some predetermined control condition. This is like our if-then statement. So if p equal to 1, then transfer the data from R1 to R2. This is what we are denoting here. Here P is the control signal generated in the control function section. If the control function is 1, then it is transferring the data from R1 to R2. Otherwise it won't transfer. So the control function is a Boolean variable. So the control condition is terminated with a colon. It shows that transfer operation can be executed only if p equal to 1. So this is control function or register transfer language notation for control function. This is, thank you. We will see in the next slides or